Hello everyone. So yeah, uh, so today we are going to start with Spring Boot API service. I have specifically designed this Spring Boot project just to let you walk through of what are the different kinds of thread pools which we can use and how we can use those thread pools basically to achieve concurrency in Java. As you see in Java world, a thread is a basic unit. Like in most of the cases, every execution which starts in Java, it actually starts with thread. So we will try to understand how these thread pools are created and how those are actually used. So I have created Spring Boot API project wherein I have exposed few APIs, and with the help of those APIs, which we can actually execute different kind of thread pools. So let's start. So this is a simple Spring Boot application which you can see. Uh, so if you see this controller, okay, we'll start with the controller. So I have designed few APIs basically, which actually executes the task with a different thread pool. Okay. So before the walking you through the API, let's have a walkthrough of what are the different kinds of uh, thread pools which we have in Java. So we have fixed thread pool where we create a fixed number of threads. So let's understand what is thread pool basically. So when we are actually executing a task in Java, we need certain threads to execute it. Thread pool is something which will have the number of threads which will be used to process the task. When we say we fixed thread pool, that means the JVM is going to create thread pool with fixed number of threads. So what does that mean? Let's say we have a fixed thread pool with count 4. So that means JVM is going to create a maximum number of 4 threads to execute the task. Okay. Then we have the cache thread pool. Cache thread pool is nothing but however number of tasks you are going to create, that many threads are going to be created by this thread pool. Okay. So this is nothing but synchronous thread pool. As soon as you receive a task, the thread is going to be created and that thread will execute the task. So that is the cache. Uh, the possible scenarios which you can execute the cache thread pool is nothing but a short-lived task. Tasks with short duration can be executed using the cache thread pool. Then we have single thread pool. So basically, single thread pool will always create a single thread, and any task you are executing using the single thread pool will always make sure that it is using the same thread again. Okay. And then we are going to use the custom thread pool. Custom thread pool will give the control over how the pools you are creating, how many minimum number of threads which you want, how many maximum number of thread you want, and then which type of queue basically you want to store the task while executing. Or it can also define the failure mechanism which you need to handle basically in a custom thread pool. That's the custom thread pool. And the last one is the fork join pool. Fork join pool is something the internal thread pool in the JVM. So if you see the streaming operation which we have starting from Java 8. So all those streaming operations internally use the fork join pool. Okay, so you have parallel operation, you have parallel stream operation. So all those operations internally use the fork join pool. Okay. And then we have the scheduled executor service. This is the scheduled thread pool. Scheduled thread pool means that when you are submitting any task basically to the JVM with some delay, that means the task is already submitted to JVM for execution. But if you have configured some delay, so JVM is going to make sure that after the delay only your task is going to be executed. That additional delay is provided in the scheduled task basically, which is not there in all these fixed or cached or single or custom thread pool or fork join pool. Okay, so that's the basic difference. Now let's come back to the Spring Boot API. Okay, so if you see this controller, so we have submit API, and then we need to define what type of thread pool which you want to submit that particular task. Okay, and then you have schedule API. Schedule API is used to trigger the task using the schedule thread pool. Okay, so this API have additional delay which we can pass in the API. Okay, and then we have get task ID API. So this basically API will tell us what are the tasks which we are actually submitting here. We can actually see the status of those tasks. Okay, and it will clearly give us the detail about which thread has executed that task and how much time JVM took basically to execute that task. Okay, this will give you the quick glimpse basically to understand different thread pools. All right. So let's start with the quick Spring Boot config. I will upload this API project on Bitbucket and will share later. So just understand the config basically which we have created. Okay, so this is the config class, and here you can see I have created different types of pool. So this fixed pool is have the fixed thread pool with max number of thread 4. Okay, then we have cache pool. So this is created using new cache thread pool. Now this thread pool is going to create as many threads required by the JVM. So if you're going to submit 100 tasks using the cached pool, then cached pool is going to make sure that 100 threads are created one after another. This is a synchronous queue basically. Then we have single pool. Single thread pool is always going to create a single thread. Then we have schedule pool. Schedule pool, we can define how many threads you want at the start. So this will actually create the two threads basically, and those threads will be used to schedule the task. And then we have the yeah, we have work scaling pool. Now, what is the work scaling pool? So basically, if you use the Java streaming operation like parallel or parallel stream, those operations are internally using fork join pool basically. Okay, so this fork join pool is basically created for parallel streaming operation, and this join pool basically created only from stealing pool basically. What is that stealing pool? Work stealing pool. So if you see this executor, it has new work stealing pool method available. Now, what does that mean? Stealing pool means JVM doesn't know that uh, I'm going to get this many tasks to execute, right? So when you say that, let's say I want to execute 10 tasks parallelly, now JVM has to steal pool. It has to create the new pool dynamically, basically, to run the task in parallel. So how that JVM is going to make sure that how many threads JVM has to suppose create. So basically, what it will do, it will go to the runtime environment and it will check the available processor. And once it takes the available processor at the time of application, that thread pool will be created using the available processor threads. Okay, so this specific thread pool is basically used for executing parallel tasks. Okay, so you can see here basically we are used this new work scaling pool. Okay, and if you are executing any task using this specific scaling pool, then you can clearly see the threads which are actually used are from the fork join pool thread pool. Okay, so it's pretty easy to understand. The fork join pool thread is basically actually created by the work scaling pool. So this is the primary scaling pool which is responsible for creating the fork join pool, which in turn used by the parallel streaming operations, right? And then we have the custom pool. If you see the custom pool here again, we have the core pool size, then we have the max size, then we have the time to live, then we have the queue, then we have the default factory, and then we have the run policy. Okay. So now what is this custom thread pool policy? Basically. So custom thread pool. So if you are executing any task uh, using custom pool, okay. So the at the start it is going to create two threads basically. So let's understand the example. If you have 50 tasks, okay. So when for the first two tasks, core pool size will be used. So two threads are created. Then you have 50 size, right? So you all the tasks from task number 3 to task number 53, right? Will be stored in this blocking queue. Okay. And JVM will make sure that all the 50 tasks are executed using the core pool size. Now, when this maximum size will be used, so if we are submitting, okay, more than 52 tasks, So all additional tasks, like tasks starting from task number 53, the new thread will be executed. Okay, so thread pool will create new threads. So max capacity is 8. So there is still scope of creating 6 more threads. So task number 53 till task number 59 will be executed by this additional 6 thread. Understood? Now any threads beyond this capacity, so any task beyond this max full size and exceeding this capacity will be processed by the current main thread. So this is nothing but that JVM is going to use the caller run policy. So this caller run policy is nothing but the handler policy. What it is defined that any task beyond the capacity will be processed sequentially from the main thread. So that's how this custom full takes care of executing tasks. Okay. So let's see now. Uh, let's see from API perspective how this going to execute the task. Okay. So let's say I'm using the single thread pool and I'm passing a task name and I'm giving task time 1000 millisecond basically. So I'm expecting my task will take minimum 1 second to execute. I am posting this task, got this ID. I will get the status from this API. Now you can see here, it is saying the task has been completed. Task has been executed by pool 5 and thread 1 and it took exactly 1 second, right? Now, if I again execute new task, the same thread pool and the same thread ID is going to be used. Okay, so let's say I'm re-executing the task again. Uh, I will get the new ID. This is the new ID. Again, I will check the status of this task. Okay, it took again exactly 1 second. But if you see the thread which it has executed, it's again same thread. Okay, it is coming from pool 5 and thread 1. So what does mean pool 5 and thread 1 basically? So JVM creates the thread pools in order. Okay, so this specific single thread pool has assigned a number 5. So this is the fifth thread pool which is created in JVM, and within that you have multiple threads. But now it's a single thread pool, so you are going to always have a single thread. So that means thread number 1. So this says that you are using thread number 1 from pool number 5. Understood? So that's very simple. So if you execute any more tasks, those tasks are going to be executed by the same thread and the same pool number 5. Now let's just see. Let's try executing the task using different thread pools. Let's say we are going to use a fixed thread pool. So I'm submitting the task using fixed thread pools. Copy this ID and check the status. So if you can see here, this is a fixed thread pool. So fixed thread pool is is the number 3 pool, and this task has been executed by the first thread within that pool, and it took 1000 milliseconds to execute. Right now, if you again execute any task using the fixed thread pool, you got the second ID. Now check the status. So earlier task got number 3 pool and number thread 1. Okay, so it's a pool 3 and the thread 1. Now if I check this task, again this task is executed by the same pool. Okay, pool 3 and the second thread. So now this is actually giving us a clear explanation that fixed thread pool is actually using the fixed number of thread and the same pool. So currently we are using the pool number 3 and second task is being executed by the second thread. Okay, now if you execute one more task, copy this ID and now get the task. Now if you see, it has been executed by thread number 3 and pool number 3. Okay, so this clearly tells that fixed thread pool is actually creating different number of threads Okay, within the same pool. This is a pool number 3 and thread number 3. Okay, so all this three execution you can say only thing which has changed is nothing but the thread number. Pool number remain constant. That means different threads are used from the same pool. Okay, now if I execute two more tasks, the thread 4 is going to be used, and again for the fifth task, again thread 1 is going to be used. That means only max 4 threads which are actually created at the startup are going to be reused now. And if there are no more tasks basically getting executed by this fixed thread pool, then all these 4 threads are going to be destroyed. And then again it will start from thread 1 when new task arrives. Understood? So this is all about the fixed thread pool. Then let's say you want to execute using the uh, let's say you have custom thread pool. Okay, so I will pass the custom here. Now you got the ID. Check the status of this ID. This time you are going to see different pool number. So now this is pool number 6, thread 1. Okay, like this because this is a custom pool. Okay, so JVM has created custom pool and it has assigned pool number 6 to custom pool. Okay, and it has took and it has taken exactly 1000 milliseconds, so 1 second. Okay, now let's see the example of scheduled pool. So scheduled pool is always execute task with some delay. So let's say I'm giving my task 10 seconds to process and I'm adding additional delay of 5 seconds. So in ideal scenario, in normal executor pool, basically in normal pool, thread pool, a task would have taken 10 seconds. But this scheduled pool will take additional 5 seconds. So your processing time ideally should be around something called 15 seconds. So I will execute this particular API. Now you got this task. Okay. Now let's see the status of this task because this is scheduled pool. Now this task is still running because I have given 10 seconds. Okay. So this task is going to be completed after 10 plus additional 5 seconds because that is delay. So you can see this. This task has taken 15,000 milliseconds approximately. So 10 second, original 10 second plus additional 5 second delay. So that's the benefit of scheduled pull basically. Scheduled pull is going to take care of your original task duration and it is also going to consider your additional delay in millisecond. Okay, so that's how you can see different thread pools are being used. Okay, so what we have covered in today's session, we have covered the post API, which is actually responsible for submitting a task using different thread pool. We have created separate API to submit the task in scheduled thread pool. Okay, so this schedule API is basically used to process the task in scheduled thread pool. Why I have done so? Because this specific API requires additional delay in millisecond. Okay, while this API remaining thread pool doesn't require any delay to process. Okay, those tasks will be processed immediately as per the thread pool provided. This scheduled thread pool requires additional delay. So I have configured this delay basically for the scheduled thread pool. And then we have get API as well. So which actually gives the status for that particular task. So this is simple application. You can use this to post API to submit the task. And then whenever you submit a task, use this get API, pass the task ID and take the status. Okay. This specific API will also will let you know which thread pool it has that particular task has been executed. Okay, so this is simple application which you can go through. I will just push this code into the Bitbucket, which you can refer later. If you have any doubts, you can reach out to me, and I hope you are pretty much clear about the Java thread pools. What are the different types of thread pool which we can use? In the next session, we will try to cover the business use cases like which thread pool should be used basically in under what scenario. Okay, so we'll try to identify certain use cases, possible use cases wherein we can define different thread pools. Okay, as per our requirement. Okay, so okay, just before we close the session, we will execute one task using the scaling pool. Okay, why I'm uh, showing this because this scaling pool is internally using fork join pool. Okay, so any Java streaming operation like parallel streaming operations are executed by fork join pool, and this join pool basically is created using this factory scaling pool factory. Okay, so let us test one task using fork join pool. Okay, so what I'm going to do now, I'm going to give this as an input. Okay, I will submit this. I got this task ID. Okay, so I have submitted the task using fork join pool. Okay, now check the status of this task. You will clearly see the thread name. Can you see this? This is task has been executed successfully, and internally it has used fork join pool thread and worker number one. Okay, so I think this is pretty much clear now that what are the different types of thread pools and what are the different types of uh, threads it is creating to execute the task. Okay, so let's catch up in the second session to talk more about how we can identify the best business cases, technical cases uh, to use these different thread pools. Thank you.